welcome to my video, lesson 4.6b on polarization. So most light vibrates in all directions at once. This is because light is three-dimensional, it's a 3D wave. However, we have filters that can allow only one type of light through. We call this polarizing. So we can polarize light, or we have polarizing filters, and then afterwards we have polarized light. This reduces the apparent brightness of the light because we have taken away any component that is not in agreement with the polarization filter. It only allows the component of light that is oscillating in the same direction as the filter to pass through. So here we have a picture of what that looks like. We've got light bouncing in all directions, oscillating in all directions kind of simultaneously. But once it goes through this polarizing filter, it takes the component of all of those and only lets those through. Now, it's kind of a misnomer or misunderstanding if you think only the red gets through and not the pink. It is true that none of the light brown or tan or whatever, none of that gets through because it's completely perpendicular. But it only allows the component of light. So, yes, it allows all of the red to get through, but it also allows the component of this purple one or pink one. It also allows the component of this one here, whatever that would be. So the vertical, only the vertical components of each. Okay, and then at the end of that, it would add all those together, so it would be taller than just the one by itself, but there we have it. Okay, so it only allows one type of light through, whatever's oscillating in that direction, but it allows that component of light through. So if you send, so here's a picture. If you try getting vertical oscillating light through a 45-degree filter, you can use vector components to find the portion of light that makes it through. So here's the vertical oscillating light. So this is the light, and here is the filter. And what you can see is that this filter is off at a 45-degree angle. And so therefore, if we were to find the component of the light that's in that same direction, you have to finish drawing the triangle to find the component of light. Well, the component of light has to be in the same angle, so it's going to have this 45 here to get you to that point. So, or if it's 45 there, it's also 45 here. So this is 45 degrees compared to the horizontal. So if we're looking for the component that makes it through, it's only this component down here that makes it through. So if this is, I'm just going to make something up, if this has an amplitude of 1, whatever that is, then this has an amplitude of 1. So if we're solving for this other side, actually you can use, and it's a 45, you can use your special triangle rules from Math 20-1. And this is special triangle 1, root 2, root 2. You can also remember this or figure this out using Pythagoras, like this. Considering a and b are the same, it's really 2a squared equals c squared. And since we know c squared, we're solving for a, we're just going to move that stuff around until we get that. There you go, there's the issue. So c is 2, so it's 2 root 2 root 2. There you go, that's much better. So when you get this, you get 4 over 2, which is a squared equals 2, which is a equals square root of 2. So this is a proof for that Math 20-1 concept of the special triangle, which is right there. So if you're curious, that's where it comes from. Now, we don't actually need to know that in Physics 20, or Physics 30, I should say. This is just a helpful piece of information to know about, but it's not necessary. What component or what portion of light makes it through? Well, it's this component of light, right? Now, you could use, you could also use cos of the angle equals adjacent over hypotenuse, and you get h cos theta equals a. This is what we would normally recommend in physics 30, and this a is that root 2 that we're going to find. So how much of the light gets through? Well, if we compare the two numbers, this is the original, and actually we're trying to figure out how much is getting through. So the bottom is the original, this is the result of it. So this is what it would look like, or we can also plug that in our calculator, and it's somewhere close to half, but not quite half. Actually, I'm just calculating it right now, about 70, let's just say 71% of the brightness should be making it through, of the light should be making it through. So you could actually test this with a lux meter on your phone using that Science Journal app, Arduino Science Journal, and you take one polarizing filter, and no matter how you orientate it, it should always allow 71% of the light through, because all light is kind of going at it, so it should be letting 71% of light through. Although that would be the halfway mark. No, it'll let exactly half the light through. Is that right? Yeah, because half of the light will be in the other direction. So normally it'll let exactly half the light through. Okay, sorry about that confusion. Okay, so here's another interesting example. Here we have two filters that are in the same direction. So once you polarize all the light through, about half of it makes it through. At that point, you have it all oscillating up and down. The second filter actually does nothing at this point. So the second filter does nothing because it's already oscillating in that direction. So it's so happy to continue to oscillate at that direction. Okay, so the second filter in this case doesn't do anything. But now if we change this and we make the second filter horizontal, now the first one is making everything vertical. All that vertical stuff does not pass this horizontal one, so that's why we have no waves afterwards. And so two polarizing filters going in opposite orientations will completely block the light. So what happens when we add another filter through between the two filters above? So if we put another filter and we try to draw it, we'll see if we can get this drawing nicely. Okay, this is my other filter here. Okay, and so this second filter, what this is going to do is it's only going to allow light that is going in the diagonal direction, but it's going to allow a little bit less of the light through. So as we found before, roughly root 2 over 2 amount of the light is going to get through. Okay, continuing to the next one, again it's going to be another 45 degrees. So then it's going to go in this direction, and it's going to be another root 2 over 2 compared to the original. So this is about half of the light. And so if you stack these filters on each other, you can multiply them and see what you end up getting, because it's kind of twisting along the way. And so by adding another filter, you actually don't reduce the amount of light, you actually increase the amount of light, and that is a super weird result. Actually, if we multiply all this, we get 2 over 8, or 1/4 of the light will make it through. Is that right? Yeah, 1/4 of the light makes it through all the way till the end. So much, much less of the light compared to normal. Okay, so yeah, here are a couple example questions that you can try. Now it's not going to be perfect here, but it says for question 1 we've got 2 polarizing filters. If you see about half the light gets through, give the orientation of the filters relative to each other. So what this is going to do is if you have one this way, then half of the light gets through. And then if that's what happens after the first one, the second one has to allow all the light through. So it has to be in the same direction to allow all the light through. So they must be same orientation. Either both vertical or both horizontal or both 45, whatever you need, but they have to be the same orientation. If no light gets through, what is their orientation relative to each other? Well, then you would have one this way, which allows half the light through, but now all that light is going vertically. So if you make the second one this way, or 90 degrees to each other, then none of the light will get through. If about 1/4 of the light gets through, then what could be the relative orientations? This one's going to be a little bit annoying. So if you get half the light getting through over here, this must be at some sort of angle to allow 1/4 of the light. So another half the light getting through here. So multiplying to get that 1/4. So somehow this must be allowing half the light through. So actually, I think we can do this actually. What is it? 2 root 3 and 1. So given this is one of the special triangles, this is the shorter side, which means that's the longer side, which means this is 60 degrees, this is 30 degrees. What now? Hold on. The closer to 90, the less. So it must be. If you want to get an actual number answer, the answer would be 60 degrees relative to each other, although we would never ask that in physics 30, not as far as I know anyway. You could do this calculation and get there, okay, based off of the orientation stuff that we did previously over here in green. Okay, one last question to try. Design a system of polarized filters that allows about 1/8 of the light to get through. So it doesn't tell you how many, it just says a system. So you could use 2 to make that happen, or you could use more. So if you wanted to get 1/8, if you did the same thing as the last question and had one at an angle like this, and then one at another angle like this, you would be able to do 1/2 times 1/2 times 1/2, where this one is 60 degrees compared to the previous one, and this is 60 degrees when compared to the previous one. And so by using 3 filters, each with a half, you could multiply those together and you would get 1/8. Again, reasonably, we wouldn't really ask this in physics 30, but logically, I think you guys can think about it and figure that out. All right, and you could use other amount of filters, right? All you have to use is you have to start with one that's 1/2, and then if you wanted to do it differently, you could get one with 1/4. And if that's what you wanted to get, then you'd have to have a triangle like this, and you'd have to find the angle in between there that would make that work. So whatever angle that would be, I'm guessing somewhere around 70 or something like that, but whatever that angle would be would also work. So actually we can just plug that in and try it. Yeah, so this says in my calculator 76, rounded to 76 degrees relative to the previous one. So you could certainly try all of these different versions out if you wanted to. They're not too complicated to go from one or the other. But the main idea with polarized light is the idea that light, because it is a transverse wave, it only oscillates in one direction or the other. Longitudinal waves do not act this way. So sound waves you cannot polarize, but any transverse waves, so water waves or light waves, can be polarized either vertically or horizontally, and that makes all the difference in the world. And so that's part of the reason why we think light is a wave. I hope this video helps you better understand polarization, and good luck.